Okay, so for this video, we're going to go through the notes on using matrices, but I'm just going to do it in two parts because matrices can take a while to solve. So one thing you want to be able to do is convert a system of equations into a matrice. So, for instance, if I give you 2x plus 3y is equal to 7 and 3x minus 4y is 24, if you wanted to set this into a matrix, what you do is you take the coefficient from each entry, and so we have 2, 3, and 7, and 3, negative 4, and 24, and this would be your augmented matrix. What that means is it's a matrix that we can actually solve for these values to get answers for. It's another way of solving system of equations. With that being said, what if I gave you and 3x equals 24? Well, if we were to make a matrix for this one, now we have 2, 1, and 8, and 3. Well, we don't have a y value, right? So 0 and 24. So it can still be done. And the thing to mention, matrices are declared by rows, number of rows, by the number of columns. There is 2 rows. I'll write this right down here. And 1, 2, 3 columns. So this is a 2 by 3 matrix. Obviously, we use the term matrices if it's more than one matrix. So there's that. Now, we can do this thing called row-reduced echelon form. This was invented, I think, by Gauss and Jordan. Oops. Elimination. Okay, so to do this, you need the following matrix to appear. So for instance, if we were solving these ones, we would want something that looks like this. Let's say 2 and 4. And we'd consider this to be row-reduced echelon form. Why? The lead coefficient here is 1. Anything below or above it is 0. All rows on the bottom of the matrix are 0 if there are some, and I'll show you what that looks like. Each lead coefficient is along the diagonal of the matrix, so this is the diagonal, and each one is 1, and then all numbers below and above are 0. So that doesn't always happen. At the very least above, usually, but we'll see. So let's look at another example of a row reduced. So you could have the following 1, 0, 0, 2, 0, 1, 3, 2, and for instance 0, 0, 0, 0. So I just want to point out this is the example. This is the rule 2. So if you get a row of zeros, that can happen. This is still our row reduced echelon form because all lead coefficients are in this diagonal, which means just the first one. And then all numbers of 0, that's below and above, that would be right here, and so on and so forth. Now, I think everything's good to go with this. Now, there are some things you can do with these. You can switch rows, so let's look at a matrix. Sorry. Okay, so let's look at the matrix 2, 4, 6, and 1, 3, 7. We are allowed to switch rows. So we can do row 1 switched with row 2. So what does that look like? 1, 3, 7. and 2, 4, 6. So this would be row 1 swapped with row 2. It is important you familiarize yourself with this notation because it helps you keep track of the things you're doing while you're completing your process. Okay, so there's that. Just multiply by a non-zero constant. So let's use the same one. We have 2, 4, 6, and 1, 3, 7. And so what we can do is we can multiply row 1 by 3, for instance. So if we do that, we were going to multiply this whole row by 3. And now we have the following. We have 6, 12, 18, 1, 3, 7. And while multiplying by 3 may not be the best thing to do in this case, you can do it for any number. Okay, and then the last one you can do is you can multiply by a non-zero constant and then add it to another row. So let's do that. So let's, for the sake of things, we have 1, 3, 7, and 2, 4, 6. So the goal here is to get this to be 0. So what I'm going to do is I'm going to practice with this problem. I'm going to multiply the top row. I'm going to do -2 times row 1, add it to row 2, and yield row 2. Okay, this is like an equal sign. That's an arrow, but it's like an equal sign. So what is 2 times row 1? 2 times row 1, so 2 times 1 is -2. I'm going to actually write it next to this, -2. -2 times 3 is -6, and -2 times 7 is -14. Now, I'm going to add those to row 2, so row 1 will not be changed, but 2 plus this plus -2, that's 0, which is what I wanted. We have 4 plus -6, that's -2, and 6 minus 14, which is -8. Okay, and so those are the 3 rules you can apply. We will be applying those multiple times throughout this process of the next video, so make sure you familiarize yourself. You'll get plenty of practice. Thank you, guys.